Welcome to Bioinformatics.Expert. This is an additional video for the amplicon sequencing analysis pipeline. In the last video, which I did several months before, I showed you how you can use the Bioinformatic Tools online program to analyze amplicon sequencing datasets. I showed you the read connection program with which you first merge R1 and R2 FASTQ files to a merged FASTQ file. Then I showed you the global alignment tool with which you can align a reference to this merged FASTQ file. Finally, I showed you the visualization and the result merging program with which you can visualize and merge the results of the global alignment. At the end, you get such an output table in which you see the different results and the abundance of those in your dataset. I showed you the tools with an artificial amplicon sequencing dataset, which contains 10,000 reads, and 60% of those aligned perfectly to the reference, whereas 20% had an insertion and 20% had a deletion. Additionally, with a probability of 1 to 1000, a mismatch or another deletion was included into the reads. A problem, however, was that it is quite difficult to now analyze small oligos within the results. For example, if you want to analyze this oligo here, then you cannot do this easily because the program is not capable to do that. Although the program Oligo Search, which I introduced in an earlier video, can be used to search for small oligos, the output of this program is not optimal for further downstream analysis. To deal with this problem and to provide a better access for further downstream analysis, I created the program Oligo Alignment. You can start this program easily by clicking on Oligo Alignment in the tool table. First, you can insert an ID for the analysis. Actually, this is a new functionality which I recently introduced into the Bioinformatic Tools online program. When you put in an ID, you can keep track your analysis more easily. We skip that here and just continue to the file selection page. You see that the allowed file type is the alignment file from the global alignment tool. This is very nice because it means that you can run the analysis very fast, and also you can repeat this step if you, for example, want to test different parameters for the alignment. Now we have to select the FASTA file which contains the small oligo. For this purpose, I uploaded this FASTA file here. This file contains a 50 basis sequence which is part of the initial reference. Now we can decide if we want to use the default alignment parameters or if we want to change the parameters with own values. In most of the cases, the analysis works good with the default parameters. However, when we change the parameters, we can potentially improve the results. I would suggest that we now stay with the default parameters and continue to the parameter table. First, we can select how many results should be shown in the output table. As a default, the top 10 results are shown. However, we can change this value to show more results. Then we can select how many mismatches are allowed in the oligo in order to merge different results. For example, when we put in a 1 here, then 2 oligos which only differ in one base will be merged in the results table. Finally, we can define the identity threshold. This value defines an abundance threshold. All bases which have a lower abundance than this value in a merged result are marked as ambiguous bases. Now we can start the analysis. A custom R script is now executed which performs the analysis and creates the output. The output is provided as HTML reports file, as 2 PDF files, and as a tab delimited text file. When we open the HTML file, we see the results in table format. On top, we see the parameters of the analysis, the number of reads, the number of unique results, and the number of shown results. We also see the alignment parameters. These are the default parameters, but as I said, you can change them in the preparation of the analysis. Next, we see the legend of the table and the reference oligo. And then we see the results perfectly aligned to each other at the bottom of the table. This part of the table is a little bit interactive. For example, some bases are clickable when they are bases which are in front of an insert. We can click on them to show the insert. Additionally, we can show the alignment of the results here. And we can also inspect the inserts by clicking this button. We see that the insert comes after the reference base 19 in this case. We also see in the table that the number of reads or the percentages of reads are similar to the values which we got in the global alignment. However, the results are a little bit larger because the global alignment algorithm does not count results which differ in some base positions outside of the searched oligo. Additionally to the HTML file, PDF files were created which contain the same results. In one of the PDFs, the inserts are shown, whereas in the other PDF, the inserts are not shown. Finally, the text file local oligo table is a tab-delimited text file which can be imported into Excel for additional analysis. Alright, thank you for watching this video about the Oligo Alignment program. I hope that this program supplements the amplicon sequencing analysis pipeline and helps you to create even better data with your data sets. The amplicon sequencing analysis pipeline is part of Bioinformatics tools online. If you want to analyze amplicon sequencing data or other data sets like RNA-seq data sets, then write me an email or visit my webpage to get a 2 weeks free test account.